Well, here we are, day 3 in our algebraic review. Day 1, we talked about square roots. Day 2, we talked about simplification of radical expressions. And here we talk about the solution of a particular kind of equation called a quadratic. You will find that quadratics arise quite often in the chapter on similarity and the chapter that follows on right triangles, which is really just applications of similarity. And you will find that these come up very often in the myriad as well. So we need to know how to solve them, and we need to know how to simplify the expressions that result. Actually, the second part of that, the simplification of the expressions that result, we've really covered already, because typically you end up with a radical in those, and we know how to simplify radical expressions. Okay, so what's a quadratic? First of all, I know you've seen this before in your Algebra 1 class, probably towards the end of the year, and you talk quite a bit about how it is that you can solve them. There are various ways that you can do this. You can factor, you can complete the square, and so on. But we will talk about one particular way to solve them by use of the famous quadratic formula, which always works. Okay, so quadratics, what kinds of equations are those? Well, they're equations that can be written in the form ax squared plus bx plus c is equal to 0, where that coefficient of a does not equal 0. This is standard form for quadratics, where you have everything on one side and 0 on the other side. And do note here that a, b, and c are coefficients, they're real numbers, and x is the variable. And notice that what really makes this a quadratic is that x occurs with the power of 2, but at no higher power. That's what makes a quadratic. Your variable is squared. So here are some examples and non-examples. So 2x squared plus 3x minus 7 is equal to 0. You see the x squared, its coefficient is not 0, it's 2, so that's a quadratic. Then you have 7x plus 12 is equal to x squared. That's definitely a quadratic as well. It's not in standard form, of course, but it's still a quadratic. If you were to write this in standard form, you'd subtract the 7x and 12 from both sides. So that would become, and we'll have to do this sort of thing in just a moment, x squared minus 7x minus 12 is equal to 0. And then you can see it explicitly in standard form. And then finally, x squared minus 4 is equal to 3x squared plus 2x. I won't write this in standard form, but do note that if we were to get the x squareds together on a side, we would end up with, well, either a 2x squared or a negative 2x squared. But we would have the x squared with a coefficient that is not 0, so that makes it a quadratic. Okay, so here are some non-examples. 2x minus 7 is equal to 0. There's no x squared, so obviously not a quadratic. Second one, 3x squared minus 2x is equal to 3x squared plus a 7. You might think it's a quadratic because, look, there's the x and there's an x squared. But think about what happens when you do sort of the first step of simplification of this expression. You would subtract the 3x squared from both sides, and that then becomes 0. So you're left with no x squared, or just the 0x squared, which means that this isn't really a quadratic. And then final example, x cubed minus x squared plus 5x minus 9 is equal to 0. There's no way to eliminate the x cubed out of this, so it's there, which means that we have x to a power higher than 2, which means that this cannot be a quadratic. That's called a cubic, actually. Perhaps at some point in your mathematical career, you'll discuss cubics and how to solve them. So how do we solve quadratic type equations? Well, in simple cases, we could do it manually without the help of any formula at all. Like, for instance, x squared is equal to 98. What would you do? We've seen this, right? So you take the square root of both sides. So I would get the square root of x squared is equal to the square root of 98. You know that the square root of x squared is not simply x. It's the absolute value of x. So the absolute value of x is equal to the square root of 98, and so on. I won't actually take us through this. You would have to, of course, simplify the expression square root of 98 if possible. If it has any perfect square factors, it's possible. And then you would end up with x equals positive root 98, or whatever it simplifies to, and x equals negative root 98. The second one, 3x squared is equal to 54, only slightly more complex. The way that you would solve this, probably, is you would divide both sides by 3 initially. So on the left-hand side, we would end up with x squared, and on the right-hand side, we would end up with 18, I suppose, and then we would take the square root of both sides and so on. We could do it, right? So a simple case like this. But those are very simple quadratics, and all quadratics are not like that. How about this quadratic? 2x squared minus 3x minus 5 is equal to 0. How would you solve that? Well, if you haven't done any work, if you haven't been shown anything about solution of quadratics, that's really far from obvious how you would do that. I mean, what would you try? I've seen students do this. Maybe isolate the x squared, and then let's see. I'll just show you what that would be, um, if you were to isolate the x squared, then you would add the 3x and the 5 to both sides, and then you would divide both sides by 2. So after just a little bit of algebra, you'd end up with this. X squared is 3x plus 5 over 2. And I don't mean to say you should do this. You absolutely should not. It won't work. I just want to make it clear that it doesn't. And then what would you do at this point? Maybe take the square root of both sides. And then you'd end up with this nasty expression, the square root of 3x plus 5 over 2. And I defy you to find any way to handle that so that you can actually solve it. And of course, the problem is this, is that you have the variable then on both sides of the equation. And then, you know what? Well, there is a way to solve these. And I won't take the time to prove this with you. You could easily find derivations of the quadratic formula online. If you're curious, go look. It's basic algebra. But what you have is this. Okay, so let's say you have a quadratic equation written in standard form. Okay, that's important here, where the assumption is it's in standard form. The formula that will always solve that is this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I know you've seen that before. That's what we will use in this class to solve quadratic equations. Now, if you've got some other way that works in a particular instance, ultimately all I care about is that the solutions are correct, but know that this always works, okay? Well, what does this mean? How do we interpret the quadratic formula? As for the a and the b and the c that are contained in it, those are the a and the b and c from standard form. That is ax squared plus bx plus c is equal to 0. Those are real numbers, okay? Those so-called coefficients, they're real numbers. They don't contain a variable. So, you know, when you plug into the quadratic formula, you don't plug a variable in, so don't do that. And then the plus minus means that we have two solutions, one when we add and one when we subtract. So typically what you get when you apply the quadratic formula is a pair of solutions, two solutions. And that should come as no surprise, really. Because, I mean, think about simple quadratics, like, I don't know, x squared is equal to 4. I mean, you take the square root of both sides, and you get square root of x squared is equal to square root of 4. And the square root of x squared is absolute value of x. Square root of 4 is 2. So you end up with absolute value of x is equal to 2. And we know that has two solutions, right? 2 and negative 2. So in those very simple cases, we get two solutions. So it should come as no surprise that we get two solutions here as well. It also comes as no surprise if you interpret quadratics graphically. Quadratics are actually graphs. The graphs that correspond to them are parabolas. The solutions of quadratics correspond to the places where those parabolas cross the x-axis, and typically, not in all instances, but in many, a quadratic will cross the x-axis twice. So do not be surprised if you have two solutions. Now, it's not inevitable that you'll have to, but it's certainly a possibility. Now, how to use the quadratic formula? Okay, so here are the steps. You take your quadratic equation, and you will have verified that it's actually quadratic, of course. We talked about that. You'll write it in standard form. That means you'll get everything on one side and 0 on the other. Then you'll peel off the values of a and b and c, and typically I'll write those out like a equals some real, b equals some real, c equals some real. Then I'll plug those values of a, b, and c into the quadratic formula, and then I will simplify, if possible, and typically you can, the expression that results. Okay, so here are the possible outcomes from the quadratic formula, and it all depends upon the expression that's under that radical, which was the b squared minus 4ac. That has a name. It's called the discriminant, not that the name is really important for us. If that discriminant is positive, we will end up with two solutions. If that discriminant is 0, we'll have only one solution that's, as it were, given twice over. And then if that expression b squared minus 4ac, the discriminant is negative, we'll have no solutions at all. Because in this class, we're only concerned with real numbers. And in this class, we can make no sense then at the square root of a negative number. Okay, so let's do some examples. Okay, so first one, 2x squared minus 3x minus 5 is equal to 0. And let us use the quadratic formula. Notice that this is already in standard form. That is, we have 0 on a side. So first order of business is to peel off the values of a and b and c. So a is the coefficient of x squared, which is 2. B is the coefficient of x, which is negative 3. C is that final real that hangs out at the end, which is negative 5. And then we plug into the quadratic formula. Okay, so what are the possible values then for x? Well, negative b. Maybe you have to go back and look at the quadratic formula again. Maybe it would be good for you to just write it down somewhere so you can refer to it. But what it says is negative b. So we have the negative of negative 3. I'm going to write all of this out. And then there's the plus minus. And then it's the square root of b squared So that's negative 3 squared minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a, which is 2 times 2. Now, you might well simplify your work a bit, skip a few steps, but here initially I won't do that. I think I will on the later ones we'll do. So 2 times 2 on the bottom. Some possible mistakes here. Look under that radical expression. What it asks us to square is b. Okay, so in this case we square negative 3, which will be a positive 9. So that b squared term will always be either 0 or positive. Okay, so don't do something like square 3 and get 9 and then take the negative of it. That would be incorrect. And notice as well that we have 4 times 2 times negative 5 under the radical, which will be a negative. So we'll have minus a negative, which will be a positive. Okay, so let's continue our work on. So on the top, we have the negative of negative 3, which is positive 3. And then we have plus or minus. There, once again, are the two solutions, once when you add, once when you subtract. And then under the radical, we have negative 3 squared, which is 9. And then I have minus 4 times 2 times negative 5. 4 times 2 times negative 5 is negative 40. And then we have minus negative 40, which means positive 40, of course, and all over 2 times 2, which is 4. So we then get 3 plus or minus the square root of 49. Ooh, that's nice because it's a perfect square all over 4. The square root of 49 is 7. So we have 3 plus or minus 7 over 4. And then typically in a case like this, where we're not left with a radical expression, we'll actually break this into its two solutions. So one solution would be when we add, which would be 3 plus 7 over 4, which would be 10 over 4, which of course could be simplified to 5 over 2. And the second solution would be 3 minus 7 over 4, which is, put a comma between these, which is negative 4 over 4, which is negative 1. So there are the two values of x, the two solutions that make that original equation true. Okay, so let's do another. 2x squared minus 3x plus 5 is equal to 0. So peel off the a and the b and the c. So a is 2, b is negative 3, and c is 5. And I don't think I'll do as much work as I did in the other. I think we can probably skip steps. So what are the possible values of x? X equals negative b, which is positive 3, plus or minus the square root of b squared. B squared is negative 3, so b squared is 9, minus 4 times a times c. Okay, 4 times a times c is 4 times 2 times 5, which is 40. Notice in this case, it's not a positive 40 because c is positive 5, it's negative 40, and all over 2a, which is 2 times 2, which is 4. And then notice, we're about to just simply stop because we will end up with negative 31 under the radical. And in this class, we do not take square roots of negatives. Life will change in Algebra 2 when you will be introduced to the imaginary number system, the complex numbers as they're called. But in this class, sort of classic geometry, we don't allow ourselves, we can make no sense of the square root of negatives. So at this point, we say no solution, okay? And let's actually be really clear about what we mean. In an expanded number system where we allow ourselves to take the square root of negatives, then it will have a solution. The solution will be a so-called complex number, but there certainly are no real number solutions to that. So that's what we will write in this case. Okay, so let's do another. 7x squared is equal to 5x. I just wanted to make clear that even though this is a bit simpler, the quadratic formula will certainly work. First of all, we need to certainly write this in standard form, which would mean that we subtract the 5x from both sides is equal to 0. And then let's actually write this in standard form. That means that we need to write the value for c, which of course is simply 0 in this case. So let's peel off the values of a and b and c. So a is 7, b is negative 5, and c is 0. And let's plug into the quadratic formula. So the possible values of x are negative b, which is the negative of negative 5. So 5 plus or minus the square root of b squared minus 4ac. B squared is 25 minus 4 times a times 0 all over 2 times a, which is 2 times 17. Oops, that's a mess. Let me fix that. 2 times 17. And then think about that radical expression, okay? So we have 5 plus or minus the square root of 25 minus 4 times 7 times 0. 4 times 7 times 0 is 0, so this is simply the square root of 25, all over 2 times 17, which is 34. Oh, that was supposed to be 2 times 7. I don't know what it is with me that I like to insert ones. I suppose I like bigger numbers. So 2 times 7, which means that it's not 34. It's 14, of course. And then the square root of 25 is, of course, just 5. So I have 5 plus or minus 5 over 14. And again, typically, since this contains no radical expressions, we'll actually explicitly write out the two solutions. One is when you have 5 plus 5 over 14, which is 10 over 14. Oops. 10 over 14, which can be written as 5 over 7. And our second solution will be 5 minus 5 over 14 minus 5 over 14, which is 0 over 14, which is just 0. So there they are, two solutions. A bit simpler because the value of c is 0, but still, there it is. The quadratic formula still works. And then let's do one final problem, okay? So 2x plus 1 is equal to x squared. You should recognize this as a quadratic. It has an x squared in there, and that's not eliminable. You should know as well that the first order of business is to write this in standard form, which would mean that we would subtract the 2x and a 1 from both sides. So when we do that, we'll get x squared minus 2x minus 1 is equal to 0. So there it is, quadratic in standard form. Next order of business is to peel off the values of a and b and c. That x squared, of course, is really a 1x squared, so the value of a is 1. Don't think that it's 0, it's not. It's 1. b is negative 2. C is negative 1. And then we plug into the quadratic formula. So we have negative b, which is the negative of negative 2, which is 2, plus or minus the square root of b squared. B is negative 2, and b squared then is 4, minus 4 times a times c, so that's 4 times 1 times negative 1, all over 2 times a, which we'll just go ahead and simply write as 2. So let's see what this is. 2 plus or minus the square root of, well, let's see, 4 times 1 times negative 1 is negative 4. So we have minus a negative 4, which is plus 4, okay? So I'll go ahead and write it like that, 4 minus a negative 4, and then that's all over 2. And perhaps you don't need to see all of these steps, but I'll write them out anyway. 4 minus negative 4 is 8, so I have 2 plus or minus root 8 over 2. And this is a very simple example, but this does carry us back to the previous lesson where we talked about simplification of radical expressions. Look, it's a radical expression. There's a square root of 8 in there, so I expect you to simplify that. And the way you would do that, of course, is to look for perfect square factors. And sure enough, 8 does have a perfect square factor, which is 4. So let me just remind you of how this works. We'll write the 8 as 4 times 2. And then this becomes, I wouldn't expect you to show every step, but I did want you to see it again. The root 4 times 2 becomes root 4 times root 2. Again, all over 2. So we have now 2 plus or minus, the square root of 4 is 2, so 2 root 2 over 2. And then that does simplify. The 2 divides into both terms on top. 2 over 2 is 1, and then plus or minus, and 2 over root 2 is just simply root 2. So if you were to write them separately, and there's no real need, but I think it's kind of cool to see this, there they are. The two solutions to 2x plus 1 is equal to x squared are 1 plus root 2 and 1 minus root 2. Both of those values of x make that original equation true. And there it is. There's how you solve quadratics. This is something that we will do certainly in the next couple of chapters, and it's something that you will do all throughout the year as you work through myriad problems.